Welcome to the workshop. This is a video on looking at the deflection of the bar and what happens to the diameter as we get farther away from the chuck. So I started by using a 4140 annealed bar. It was about an inch in diameter when I started, and I've been taking small passes, 1/10 at a time on the diameter, and it has gradually gotten whittled down, but there's still enough beef left in it that we can get reasonable readings out of it. I don't think there's any doubt as to what we will see. We should see worse readings the farther away we are from the chuck, but it's nice to quantify what we end up with as well. My goal is to use a variety of different inserts and see what we end up with in terms of deflection and the type of insert. It is a little bit tedious because you have to measure all the way down the length of the bar and record the numbers, but I'll actually just take the readings right off the video and put them into a spreadsheet later. The red arrows point to the face of the jaws that I'm using as my starting point for measurements, and so the yellow bar is a horizontal line for the starting point, and the second yellow bar rather is about the half-inch mark, and that's usually where I'm taking my zero measurement from. Okay, so this is the data in a graph form. On the vertical axis we have the increase in diameter as you go along the length of the bar. So the vertical axis is actually in tenths, which is 1/10,000th of an inch, which is just over 2.5 micrometers, or 2.54 micrometers to be precise. And the horizontal axis is in stick out in diameters. Now the points don't all land exactly where you would expect them to land. They are not 1, 2, 3, or 4 diameters, because what I did was that I took the stick out and divided it by the actual diameter, so these numbers are correct in terms of the relationship of the location of measurement to the diameter of the bar. And the three graphs actually are: the red one is the first pass, the yellow is the second pass, and the green one is the third pass. And as you can see, the diameter gets bigger as you get further away from the chuck, but the green, or the final bar, actually shows the result pretty much as you would expect it. It's a pretty steady, straight increase as you go further and further out, and really even by about 3 diameters, which is where you're not supposed to go beyond, the increase in size is just about 3/10, and that is close to about 3 inches out from the chuck. And even when you get to 4.5 diameters, the increase in the diameter of the bar is 6/10, so pretty good overall. Okay, now we're looking at the graphs for the diamond insert. Once again, the reddish orange one is the first pass, the yellow is the second pass, and the green is the third pass. And as you can see by the third pass, the finish is a lot more predictable, and at 3 diameters out we have the bar being about 4/10 larger than at the base. And even at 4 diameters it's still pretty reasonable. Not sure why close to 4.5 diameters it goes down to 0, but you know, it's probably more random error than anything else. Okay, now this is the graph with the 2 passes with the round insert, and on the first pass in orange it seems to have cut more deeply than you would have expected. You know, further out from the chuck it should cut less deeply. The second pass kind of fits that, but both passes are kind of a little bit odd and not as predictable as one would have expected. Okay, now this is after I took the bar out of the chuck and put it back in. So this time I did 6 passes, and there's a reason for that. If you look at the first 3 passes, they're the usual colors, orangey red, orangey yellow, and light green, and they're the lighter graphs. These points are kind of all over the place, and at 2.5 diameters, 2 to 3 diameters out, The second pass is about 2.5 thou out, and gets better as you go further out into the fifth diameter, but still not very predictable, not a very steady increase in size as you go further away from the chuck. And then after the first three passes, then passes number 4, 5, and 6 are heavier lines, light blue, gray blue, and bright yellow. And there you can see that the results are much better. At 3 diameters out, we are anywhere from 2 to 5/10, and by 4 diameters it is getting to be about a thou out, and by the 5th diameter we are at 5/10 to 1.5 thou out of the size that we wanted. Okay, now this is the graph of the 80-degree diamond insert, and as you can see, all 3 passes seem to be following a very predictable line, and certainly by 3 times diameter you are at about 4 to 5/10 out from your target, and it becomes unusable at 5 times, well, anywhere from 4 to 5 times the diameter. And now this is the graph with the tailstock in place, and as you can see, the variation in diameter is minimal. I've kept the vertical axis the same as on the previous graph to give a nice visual comparison, but the variation is 1/10 or less all the way along the length of the bar, and it goes to show where if you can use tailstock, it is an excellent idea. And this is one final graph. I went ahead and ran an emery cloth with oil over the stock just to see how much would be taken off. Now I should have kept track of the exact time I was taking, but the interesting thing is that there's more taken off farther away from the spinning chuck than closer to the chuck, and obviously I was cranking harder on it the farther away it was. And that's all I have in this video. I hope you found it interesting, and if so, do please subscribe.